Hello science enthusiasts. Today we are talking about the basic concepts and insights on artificial intelligence. For some, artificial intelligence could be the rise of the machines, thus the doom of mankind. Not yet though. There are many scientific definitions as to what AI really is. Most commonly, though, artificial intelligence is defined as a system's ability to correctly interpret external data, to learn from such data, and to use those learnings to achieve specific goals and tasks through flexible adaptation. Colloquially, the term artificial intelligence is often used to describe machines or computers that mimic cognitive functions that humans associate with the human mind, such as learning and problem solving. Artificial intelligence was founded as an academic discipline in 1955, and in the years since has experienced several waves of optimism, followed by disappointment and the loss of funding, known as an AI winter, followed by new approaches, success and renewed funding. AI often revolves around the use of algorithms. An algorithm is a set of unambiguous instructions that a mechanical computer can execute. A complex algorithm is often built on top of other, simpler, algorithms. The overall research goal of artificial intelligence is to create technology that allows computers and machines to function in an intelligent manner. The general problem of simulating or creating intelligence has been broken down into sub-problems. These consist of particular traits or capabilities that researchers expect an intelligent system to display. The traits described later on have received the most attention. 1. Reasoning, problem solving. Early researchers developed algorithms that imitated step-by-step reasoning that humans use when they solve puzzles or make logical deductions. By the late 1980s and 1990s, AI research had developed methods for dealing with uncertain or incomplete information, employing concepts from probability and economics. 2. Knowledge representation. Some expert systems attempt to gather together explicit knowledge possessed by experts in some narrow domain. In addition, some projects attempt to gather the common-sense knowledge known to the average person into a database containing extensive knowledge about the world. 3. Planning. Intelligent agents must be able to set goals and achieve them. They need a way to visualize the future, a representation of the state of the world, and be able to make predictions about how their actions will change it, and be able to make choices that maximize the utility or value of available choices. 4. Learning. Machine learning (ML), a fundamental concept of AI research since the field's inception, is the study of computer algorithms that improve automatically through experience. 5. Natural language processing. Natural language processing (NLP) gives machines the ability to read and understand human language. A sufficiently powerful natural language processing system would enable natural language user interfaces and the acquisition of knowledge directly from human written sources, such as newswire texts. 6. Perception. Machine perception is the ability to use input from sensors such as cameras, visible spectrum or infrared, microphones, wireless signals, and active lidar, sonar, radar, and tactile sensors, to deduce aspects of the world. All of the above combined lead to the so-called general intelligence. Many researchers predict that such narrow AI work in different individual domains will eventually be incorporated into a machine with artificial general intelligence (AGI), combining most of the narrow skills mentioned above and at some point even exceeding human ability in most or all these areas. But when is this going to happen, if ever? And what would that mean for mankind? Everything leads to the technological singularity. The technological singularity, also, simply, the singularity, is a hypothetical point in time at which technological growth becomes uncontrollable and irreversible, resulting in unforeseeable changes to human civilization. A fundamental pillar of scientists' argument on singularity is that to get to the singularity, computational capacity is as much of a bottleneck as other things like quality of algorithms and understanding of the human brain. Moore's law predicts the capacity of integrated circuits grows exponentially, but not indefinitely. This roughly leads us to the year 2045. Potential impacts. Dramatic changes in the rate of economic growth have occurred in the past because of some technological advancement. Based on population growth, the economy doubled every 250,000 years from the Paleolithic era until the Neolithic Revolution. The new agricultural economy doubled every 900 years, a remarkable increase. In the current era, beginning with the Industrial Revolution, the world's economic output doubles every 15 years, 60 times faster than during the agricultural era. If the rise of superhuman intelligence causes a similar revolution, one would expect the economy to double at least quarterly and possibly on a weekly basis. Hard versus soft takeoff. In a hard takeoff scenario, an AGI rapidly self-improves, taking control of the world, perhaps in a matter of hours, too quickly for significant human-initiated error correction or for a gradual tuning of the AGI's goals. In a soft takeoff scenario, AGI still becomes far more powerful than humanity, but at a human-like pace, perhaps on the order of decades, on a timescale where ongoing human interaction and correction can effectively steer the AGI's development. But will it ever become a reality? Not everyone agrees. Most of the computer scientists today agree that a hard approach is beyond reality. They are optimistic about AI controlling our lives in a constructive and friendly way, such as prolonging life expectancy. Ethical concerns. One concern is that AI programs may be programmed to be biased against certain groups, such as women and minorities, because most of the developers are wealthy Caucasian men. Support for artificial intelligence is higher among men, with 47% approving, than women, 35% approving. Algorithms have a host of applications in today's legal system already, assisting officials ranging from judges to parole officers and public defenders engaging the predicted likelihood of recidivism of defendants. COMPAS, an acronym for Correctional Offender Management Profiling for Alternative Sanctions, counts among the most widely utilized commercially available solutions. It has been suggested that COMPAS assigns an exceptionally elevated risk of recidivism to black defendants while, conversely, ascribing low-risk estimates to white defendants significantly more often than statistically expected. What is more, the relationship between automation and employment is complicated. While automation eliminates old jobs, it also creates new jobs through microeconomic and macroeconomic effects. Unlike previous waves of automation, many middle-class jobs may be eliminated by artificial intelligence. The Economist states that the worry that AI could do to white-collar jobs what steam power did to blue-collar ones during the Industrial Revolution is worth taking seriously. The field of machine ethics is concerned with giving machines ethical principles, or a procedure for discovering a way to resolve the ethical dilemmas they might encounter, enabling them to function in an ethically responsible manner through their own ethical decision-making. The field was delineated in the AAAI Fall 2005 Symposium on Machine Ethics. Past research concerning the relationship between technology and ethics has largely focused on responsible and irresponsible use of technology by human beings, with a few people being interested in how human beings ought to treat machines. In all cases, only human beings have engaged in ethical reasoning. The truth is that as AI evolves, such dilemmas or concerns will be more and more discussed between the scientific and not only community. What is of imperative importance? Are these matters to be pre-solved, rather post-attack? So, my fellow science enthusiasts, that's all for today. Please feel free to like and subscribe for more science-related videos to come.